So in class we considered the following hypothetical data set where we looked at the effectiveness of a new therapy for depression using 16 participants who were suffering from depression and recruited by newspaper ad. We gave each one a pre-test measuring their depression levels, and then half are given a 6-week intervention using the therapy and half were put on a wait list. After 6 weeks, all were given the depression test again, and we want to know, is there any evidence here that the therapy is effective? So below I have a table that we used in class that shows that for the therapy group, their pre and post test scores, and for the waitlist group, their pre and post test scores. For the analysis here, realize that we have two variables, the time variable, pre and post, and the grouping variable, therapy versus waitlist. The pre to post variable, time, is a within subjects factor because each person is tested twice. And the grouping variable, waitlist versus therapy, is a between subjects factor because each person is either assigned to therapy or either assigned to waitlist. So to test this, we could simply do a dependent samples t-test just for the therapy group, comparing pre to post, and the second for the waitlist group, comparing pre to post. However, doing that would increase our experiment-wise error because each of those tests has a probability of a type 1 error at whatever alpha level we use. The better analysis would be to run a single test to look at the effect of time, the effect of condition group, and interaction between the two. So to do that, we're going to use a two-way ANOVA, and specifically the mixed model ANOVA, where we have one within subjects factor and one between subjects factor. So in SPSS, I've entered this data, which you can see here. I have my grouping variable, where 1 has been designated for therapy, 2 for waitlist, and I have the pre and post test scores for each person. Since there were 16 participants, there should be 16 rows in SPSS, and because each person was measured twice, I should have 2 columns, one for the pre and one for the post. If I have labeled my variables, so in variable view, or labeled the grouping variables, setting 1 to be a therapy and 2 to be a waitlist, then in data view, if you click and toggle over to the labels, you should see that everything looks perfect. I would cross-check this back with the original data sheet before running the analysis, but I think everything's fine because I did that earlier. In this case now, to do the ANOVA, recall that we're going to use the general linear model, and since we have one repeated measures factor, one within subjects factor, then you're going to go to repeated measures, and SPSS doesn't know that these two variables, pre and post, are really just two levels of a single within subjects factor. So we're going to tell SPSS that we have a within subjects factor that I'm just going to call time. I'm going to tell SPSS that time has 2 levels. And then in the next step, and that's all you need to do here, and the next step, SPSS now needs to know, well, which of the variables in my data set need to be assigned to the 2 levels of time. This is important because to keep straight, because in larger data sets, more interesting data sets, you might have many variables, and it can get confusing as to which one goes in each within subjects factor. In this case, it's pretty easy. I just have a pre and a post. If I ran the test now, it would simply give me the results that would be appropriate for a dependent samples t-test. To actually include the effect of group, I'm going to add that as a between subjects factor. And I'm also going to ask for descriptive statistics, estimates of the effect size, and that's all for the first pass. If I hit OK, then for the SPSS output, it shows me that I have a within subjects factor, time, that's made up of 2 variables, pre and post, that are the 2 levels. I have a group, another between subjects factor group that has levels of therapy and waitlist with 8 people in each condition. Gives me the means for the pre and post condition for each group. So pre-therapy has a mean of 16, post-therapy has a mean of 14, pre-waitlist 15.38, post-waitlist 15.38. It gives me output on multivariate tests. For our course, we're going to ignore this. It also gives me Mauchly's test of sphericity, which I would care about. However, in this case, our within subjects factor only has 2 levels. So in that case, we don't calculate sphericity, or we can't calculate sphericity, so we don't need to worry about it. But in general, if Mauchly's test of sphericity were significant, so if the probability was less than 0.05, then we would normally say that we have a violation of sphericity, and we would want to use the corrections below. So, however, since Mauchly's test is not significant, then we don't need to use those corrections. Generally, if it's significant, I'll still report the sphericity assumed. This is the basic F ratio in significance. But if any of the corrections gave a different result, then I would be more careful to report that these results are to use the p-value based on the corrected significance. In this case, it doesn't make a difference. In the test of within subjects effects, we can see that for the main effect of time, we had an F ratio of 2.496 with a p-value of 0.136, so it was not significant. Same for the time by group interaction. There was no significant effect of time, there was no difference in the effect of time between the 2 groups. And if you go down to I guess that was yep, that was the right place. You're down to the between subjects effects. The F ratio for group is also not significant. So there's no effect of therapy. There's no change over time, and the effect doesn't differ between the 2 groups. The effect of time isn't different, so there's no the amount of change is similar for each group. Therapy and waitlist. If you add a plot here, you can also put a plot to show the change from pre to post separately for each group. And now if you rerun the analysis, down below, yeah. So overall, there's no significant effect, because even though the therapy group showed a decrease from pre to post, the sample is very small, and the variability is large enough that this drop is not large enough to be significant. So if you're running this as a study, you would probably need to add more participants to get a better estimate to see if this difference is in fact just random variation, or if there really is an effective therapy, but your study is just not powerful enough to detect it. And I say in general, you wouldn't run an experiment like this with just 8 people in each group.